Have you ever looked up at the night sky and wondered where all those twinkling lights came from? What are stars, really? And what happens to them when they die? Today, we're going on an epic journey through space and time to uncover the spectacular life cycle of stars. From their fiery birth to their dramatic death, every star has a story. And this story is our story, because the very elements that make up our world, and even us, were forged in the hearts of these celestial giants. So, get ready for a cosmic adventure. It all begins in the vast, cold emptiness of space, inside immense clouds of gas and dust called nebulae. These aren't just empty clouds. They are stellar nurseries, breathtakingly beautiful tapestries of color, stretching for light years. Within these cosmic nurseries, gravity is the master sculptor. It starts to pull clumps of gas and dust together. As these clumps get denser and denser, the pressure and temperature at their core begin to skyrocket. This initial stage, a baby star in the making, is called a protostar. It's not quite a star yet, but it's getting hotter and brighter, a glowing ember in the heart of the nebula, gathering more and more material, getting ready for the main event. After millions of years of gathering mass, the core of the protostar becomes unbelievably hot and dense. We're talking millions of degrees. At this critical point, something incredible happens. Nuclear fusion ignites. This is the moment a star is truly born. In this process, hydrogen atoms are forced together under immense pressure to form helium, releasing a tremendous amount of energy. This outward push of energy perfectly balances the inward pull of gravity, creating a stable, shining star. Our own sun is a perfect example of a star in this phase, known as the main sequence. Stars will spend about 90% of their lives in this stable, middle-aged phase, peacefully fusing hydrogen into helium, shining brightly for billions of years. But what determines a star's fate? It all comes down to its mass. The more massive a star is, the hotter it burns, and the faster it uses up its fuel. So, paradoxically, the biggest, brightest stars have the shortest lives. Low-mass stars, like red dwarfs, are the marathon runners of the cosmos. They sip their hydrogen fuel so slowly they can live for trillions of years, far longer than the current age of the universe. Our Sun, a medium-mass star, has been in its main sequence for about 4.6 billion years and has about 5 billion more to go. But high-mass stars, those brilliant blue giants, live life in the fast lane, burning through their fuel in just a few million years before meeting a spectacular end. So, what happens when a star starts to run out of hydrogen fuel in its core? This is where the paths diverge. Let's first look at stars like our Sun. When the hydrogen in the core is depleted, fusion stops. Gravity takes over again and starts to crush the core, which makes it even hotter. This intense heat ignites a shell of hydrogen surrounding the core, causing the star's outer layers to expand dramatically. The star swells up, becoming hundreds of times its original size, turning into a red giant. Its surface cools, giving it a reddish glow. In about 5 billion years, our Sun will become a red giant, expanding so much it will likely swallow Mercury, Venus, and possibly even Earth. It's a sobering thought, but a natural part of its stellar evolution. After the red giant phase, the star's life enters its final chapter. For a star like our Sun, the outer layers drift away into space, creating a beautiful, glowing shell of gas called a planetary nebula. These aren't related to planets. They were just misnamed by early astronomers. What's left behind at the center is the star's hot, dense core, a white dwarf. A white dwarf is incredibly dense. A teaspoon of its material would weigh as much as an elephant on Earth. It no longer produces energy through fusion. It's like a dying ember, slowly cooling and fading over billions of years until it becomes a cold, dark, black dwarf. This is the quiet, graceful end for most stars in the universe. But for stars that are much more massive than our Sun, at least 8 times more massive, the end is anything but quiet. It's the most spectacular fireworks show in the cosmos. When a massive star runs out of fuel, its core collapses under its own immense gravity in a fraction of a second. This catastrophic collapse triggers a mind-bogglingly powerful explosion called a supernova. A single supernova can briefly outshine an entire galaxy, releasing more energy in an instant than our Sun will in its entire lifetime. This explosion blasts the star's outer layers into space at incredible speeds, scattering heavy elements across the galaxy. These elements, forged in the star's core and during the supernova itself, are crucial for the next part of our story. What remains after the supernova explosion depends on the mass of the star's core. If the core is between about 1.5 to 3 times the mass of our Sun, the crushing force of gravity is so intense that it forces protons and electrons to combine into neutrons. This creates an object of unimaginable density, a neutron star. A neutron star is like a giant atomic nucleus, packing the mass of our Sun into a sphere only about 20 kilometers, or 12 miles, across. A single sugar cube of neutron star material would weigh 100 million tons. Some neutron stars spin rapidly and emit beams of radiation, which we observe as pulsars like cosmic lighthouses sweeping across the universe. But what if the star is even more massive? What if the remnant core after the supernova is more than 3 times the mass of our Sun? In that case, not even the neutrons can withstand the relentless crush of gravity. The core collapses completely, compressing into a point of infinite density called a singularity. This creates a region of space-time where gravity is so strong that nothing, not even light, can escape. This is a black hole. Black holes are the most mysterious and extreme objects in the universe. They don't suck things in like a vacuum cleaner. They are just objects with such intense gravity that once you cross a certain boundary, the event horizon, there's no turning back. They are the ultimate stellar remnant, a final dark testament to a once mighty star. So, from the gentle glow of a stellar nursery to the violent explosion of a supernova and the silent mystery of a black hole, we've journeyed through the incredible life of a star. But the story doesn't end there. In fact, every stellar death is a new beginning. The elements created inside stars and scattered by supernova elements like carbon, oxygen, iron, and gold don't just disappear. They mix with interstellar gas and dust, enriching the next generation of nebulae. From these enriched clouds, new stars and planetary systems form. The iron in your blood, the calcium in your bones, the oxygen you breathe, every atom in your body, heavier than hydrogen and helium, was forged in the heart of a star that lived and died long ago. We are, quite literally, made of stardust. The universe is a grand cycle of creation, and we are a part of it. Thank you so much for joining me on this cosmic journey today. If you found this as fascinating as I do, don't forget to like this video, and subscribe to the channel for more adventures into the wonders of our universe. Let me know in the comments what cosmic topic you'd like us to explore next. Until then, keep looking up